Okay, so we have universal indicator solution in there. 2 electrodes. The red is positive. It's producing a red color, which is a pH of 4. The negative electrode is a piece of pencil lead, which is definitely turning purple, which is 10. In the middle here, we have basically indicator solution with water, which is 7. So with an electric current going through this, what are we doing to the water? It has nothing to do with the lead. The lead is just an electrode. So what happens is we have, what's in here is H2O. H2O liquid. And we're supplying this thing with a current. Now think about what water will do. If I have water, I have one reactant. What kind of reaction is this? Yes. We are decomposing water with an electric current. But based on the colors you're seeing, what are we making? Okay, if you break the, we've said this before, what do you get when you break H2O down? H and OH. H and OH is H2O. So you're making H2, and you're not seeing really, right here you are, see the bubbles? That's H2 gas. Now that's another hint for you. Why is that end turning red? And then why is this turning blue? If you're decomposing water, this is going to be aqueous because it's just OH, which is an ion, right? So this is kind of cool. The cathode we got 2 different things going on here. That's what's going on right at this one right here. No, this is the cathode, which is counterintuitive, right? Isn't red the anode? Or the cathode usually positive? Okay, it's backwards here. I don't know if it's the same way here or not, but we also have this going on the other end, which is going to just H plus H plus ions plus O2 gas. So they are both decomposition reactions, but they're different. And you're seeing some bubbling at both now. So this one is actually, okay, I'll label this for you. This one is, this is the cathode, right here. At the cathode, why is it making this? It's doing this reaction right here. This is the anode, which is doing this reaction right here. Now, tell me why they changed the colors they did. Okay, here, we got to add one other thing too. Where does the battery come in? Battery is electrons, basically. So we should do this. On the cathode, we should put 4 electrons here in the reaction, because it actually is part of the reaction, and the battery would be the thing that this would make 4 electrons here. So if the circuits quit, none of this would happen. If I didn't hook the battery to it, that's when it started, right? So we got to have electricity in the reaction because it is consumed. It's not like catalyst, okay? So what's going on here? I did that backwards. This is going to be 4 electrons. This is going to make 4 electrons. In either case, no, I did that backwards again. This is right. Okay, but the cathode is making H plus ions. That is an acid. So that's why it's going to a pH of 4 right here. And OH minus, aqueous in solution, is exactly what a base is. So you're literally making the base right. This reaction right here is your OH.
Is the white extremely acidic?
What's that?
Is the white extremely acidic, or is it just one of the others?
I think that what you're doing there is you're probably getting the oxygen is, I don't know if that, I'm not really 100% sure. There is no, the universal indicator doesn't go past red. So I don't know what the clear is. It's probably just reacted, and the oxygen is probably pushing this way, the indicator out of it. But it'll keep going and keep going unless we mess with it. So you messed with it?